Welcome to G Fun Facts Online. In the silent, black expanse of our solar system, a new gold rush is about to begin. But this isn't about panning for gold in rivers. It's about harvesting asteroids hurtling through space. We're talking about the dawn of celestial economics, a future trillion-dollar market that could reshape humanity's future. This isn't science fiction anymore. Thanks to cheaper rockets, advanced robotics, and incredible navigation systems, mining the cosmos is becoming a commercial reality. The economic plan unfolds in two phases. First, a space-for-space economy, using resources harvested beyond Earth to build the infrastructure for our expansion into the solar system. The second, more transformative phase involves bringing high-value materials back to Earth, which could reorder our planet's economy and shift geopolitical power. This is about building a self-sustaining civilization beyond Earth and securing our long-term prosperity. So what's out there? Why is this a trillion-dollar idea? Well, that figure is actually a massive understatement. The resources locked in asteroids are almost incomprehensible. Take a single metallic asteroid, 16 Psyche. Its estimated value is a mind-boggling $10,000 quadrillion. Now, if we brought all that metal back to Earth, the market would crash instantly, making it worthless. So that number is symbolic, but it shows the sheer scale. The real goal is twofold. First, to use resources in space, for space. And second, to eventually bring back high-value materials to supplement our dwindling resources on Earth. Asteroids are leftover building blocks from our solar system's birth, and they come in three main flavors. First, you have C-type, or carbonaceous asteroids. They make up about 75% of the asteroids we know. They're rich in carbon, organic molecules, and most importantly, water ice. This makes them the gas stations of the solar system. Water can be split into hydrogen and oxygen, the key components of rocket propellant. Refueling in space would slash the cost and difficulty of missions across the solar system. Second are the S-type, or silicaceous asteroids. These are stony, made of silicate minerals, with some metals like nickel and iron. Think of these as the quarries and hardware stores of space, providing raw construction materials for habitats, manufacturing plants, and other deep space infrastructure. Finally, we have the M-type, or metallic asteroids. These are the rarest and most sought after. They are believed to be the exposed metal cores of ancient, shattered protoplanets. They are packed with iron, nickel, cobalt, and the big prize, platinum group metals, or PGMs. We're talking platinum, palladium, and rhodium. Some M-type asteroids have these precious metals in concentrations thousands of times higher than anything we can find in the Earth's crust. This is crucial because materials like cobalt and nickel are vital for green technologies like electric car batteries, and our supply on Earth is getting tight. Asteroid mining offers a long-term solution. But the most significant part is what we call in situ resource utilization, or ISRU. It's just a fancy way of saying living off the land. The biggest hurdle for space exploration is the immense cost of launching anything out of Earth's deep gravity well. By using water from C-types for fuel and life support, and metals from S and M types to build things in space, we can create a self-sustaining industrial ecosystem beyond our home world. So how do we actually do this? It's a complex dance of incredible technology. First, you have to find the treasure. This is the prospecting phase. We use powerful ground and space-based telescopes with special instruments to analyze the light reflecting off an asteroid. This tells us its composition. Companies like Transastra are even building new telescope networks just to spot near-Earth asteroids that are currently too faint to see. Once a good target is found, you have to get to it. The rendezvous and anchoring phase is a delicate ballet in the void. Asteroids are often small, oddly shaped, and have almost no gravity. Just landing is tough, but staying anchored while you drill or excavate is even harder. engineers are developing some wild solutions. One idea is foam injection anchors, where you inject a fast-expanding foam into the loose surface dust, which then hardens into a solid anchor point. For metallic asteroids, you could use powerful magnets to just stick to the surface. Other ideas include auger-like drills, or even sticky screens that use a powerful adhesive. Now for the main event, extraction. How you get the goods depends on the asteroid. A company called Transastra is pioneering a technique called optical mining. It uses concentrated sunlight from mirrors to heat the surface of a C-type asteroid. This turns the water ice directly into vapor, which can be captured in a giant containment bag. It's a lightweight and elegant solution for getting water. For more solid, rocky, or metallic asteroids, you'd need robotic excavators and drills. Think of autonomous construction vehicles in space. The Asteroid Mining Corporation in the UK is developing robots called SCAR-E, or Space-Capable Asteroid Robotic Explorers, for exactly this purpose. For loose metallic dust, a simple magnetic rake might do the trick. And for some smaller, rubble pile asteroids, the plan is to just enclose the entire thing in a huge bag and then process it. Finally, you have to process what you've mined. Raw ore isn't very useful. Water ice can be melted and stored. But for metals, it's more complex. The startup Astroforge is developing what it calls an orbital refinery. The idea is to vaporize the asteroid material and then sort the valuable metals from the waste rock. This leads to in-space manufacturing. Companies like Cislunar Industries are working on space foundries that can take scrap metal or asteroid material and turn it into beams, rods, or custom parts using 3D printing. This is the key to bootstrapping a space-based civilization. As the technology gets closer to reality, a huge question emerges. Who owns an asteroid? This brings us to the Wild West of space law. The foundational legal document is the 1967 Outer Space Treaty. It says that no nation can claim sovereignty over any part of outer space. But it was written long before anyone seriously considered commercial mining. Does extracting resources and owning them count as national appropriation? It's a huge legal gray area. To provide some clarity for their companies, some countries have taken matters into their own hands. In 2015, the United States passed the Commercial Space Launch Competitiveness Act, which explicitly gives U.S. citizens the right to own, use, and sell any resources they extract from an asteroid. Since then, countries like Luxembourg, the United Arab Emirates, and Japan have passed similar laws. On the international stage, the U.S. has championed the Artemis Accords. These are agreements between the U.S. and other countries that, among other things, affirm that extracting space resources is allowed under the Outer Space Treaty. As of late 2025, 59 countries have signed on, creating a large group of nations that support commercial space development. However, not everyone is on board. Major space powers like Russia and China have not signed the accords. They've expressed concern that this is a unilateral move by the U.S. to set the rules. This creates a risk of future conflict over valuable resources in space. A clear, universally accepted international framework is desperately needed to ensure this new frontier is developed peacefully. So who are the new prospectors leading this cosmic gold rush? It's a mix of bold startups, established giants, and government agencies. The real trailblazers are the new space startups. One of the most prominent is Astroforge, a California company focused on mining platinum group metals. They've already launched test missions to prove their refining tech in orbit. Another is Carmen Plus, based in Denver, which is focused on mining water to create an in-space refueling service. Then there's Transastra in Los Angeles, with its optical mining technology. And the UK-based Asteroid Mining Corporation is building its robotic explorers. These agile companies are driving the innovation. But they're not alone. The established aerospace giants like Lockheed Martin and Boeing have the experience and deep pockets to support these massive missions. They're increasingly partnering with the startups, seeing the immense potential. And none of this would be possible without government space agencies paving the way. NASA has been a huge supporter. Its Artemis program, which aims to put humans back on the moon sustainably, relies on using local resources. This creates a built-in first customer for any company that can deliver water or building materials from space. NASA's OSIRIS-REx mission, which successfully returned a sample from the asteroid Bennu, provided priceless data for future miners. Japan's agency, JAXA, was a pioneer with its Hayabusa missions that brought back samples from 2 different asteroids. The European Space Agency, ESA, is also heavily involved. And we can't forget China. The CNSA has very ambitious plans for asteroid mining and is rapidly advancing its space technology, making it a major player to watch. So what does the world look like when asteroid mining becomes a reality? The impact will be transformative, both on Earth and in space. First, on Earth, bringing back large amounts of materials like platinum could completely disrupt commodity markets. The price could crash. This might be bad news for terrestrial mining companies, but for the rest of us, it could mean an age of abundance. Materials that are currently too rare and expensive for everyday use could become common, sparking innovation in everything from electronics to energy. But the truly profound impact will be the creation of a genuine in-space economy. This is the cis-lunar economy, spanning the space between the Earth and the Moon. By providing local raw materials, asteroid mining breaks our total dependence on Earth. We can start building a self-sustaining industrial ecosystem. The business models go way beyond just refueling ships. Think about in-space manufacturing, using 3D printers and asteroid metals to build new satellites, spacecraft components, and huge solar power stations in orbit. We could build habitats and infrastructure on the Moon. A whole service economy would spring up for satellite repair, refueling, and cleaning up space debris. The road to this future is long and full of challenges. The technology is still young, the legal framework is murky, and the upfront costs are astronomical. This is a marathon, not a sprint. It will take patience, perseverance, and a lot of investment. But the potential rewards are driving a new generation of entrepreneurs and engineers to tackle these problems. As we take these first bold steps, we aren't just reaching for rocks in space. We are laying the foundation for a future where humanity is no longer confined to one planet. A future where the vast resources of the solar system are used to secure the long-term prosperity and survival of our species. The celestial economy is no longer a distant dream. It's the next giant leap for humankind. Thanks for tuning in to G Fun Facts Online.